everyone. I hope everybody's had a great spring break. You're going to find different lessons for this week on YouTube, but I wanted to go back to last week before spring break and talk a little bit about mixed numbers and improper fractions. I saw that some of us were having a little bit of confusion with that. So we can express a number as a mixed number, which shows the whole numbers and the parts, okay, that are in the fraction. Or we can express it as an improper fraction, which just gives us all of the parts. So let's take a look at an example. If we have the number 2 and 1/4, and we want to express the number 2 and 1/4 as just all parts, as just all pieces. So I could start off by drawing a model. I'm going to draw at least 2 rectangles for the whole number, and then I need another rectangle for the fraction amount. I know by looking at this fraction that I'm working with fourths. So in order to make these wholes, okay, that each one of them must have had 4 fourths. Okay, so if I shaded in 4 fourths here, that would make one of these whole numbers. And then if I shade in another 4 fourths there, that would make my second whole number. And then down here, I'm just going to shade in one of the 4 pieces here to show 1/4. So now you can see that to create the improper fraction, all I would have to do is count up how many fourths there are in total, because I just want to express this number in all of the parts, and the parts that we're looking at are fourths. So I could just count them up. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9 fourths. So we could say 2 fourths is equal to 9 fourths. Let's take another look at an example. Let's do 3 and 2/3. 3 and 2/3. So again, I know that I'm working with thirds here. So I'm going to draw holes, and I'm going to split them into thirds. And I know in order to have a hole, I need to shade in all 3 pieces. So there's 3/3 or 1 hole. There's 3/3 or 2 holes. There's 3/3 or 3 holes. And then I know I need 2 more thirds, not another hole. So now I have modeled the number 3 and 2/3. But if I want to express this in all parts, just in all thirds, okay, then I can say, well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 thirds. So you can always draw a model to help you flip a mixed number to an improper fraction, or the other direction. But you can also think about it in a mathematical way and just use computation here. So we know that there's 3 holes, and each of those holes has 3/3 in it. So I could do 3 times 3, okay, because, well, look here, I did it. There's 3, 3, 3. There's 3 pieces 3 times. So that's 9. And then I'm going to add in, okay, I'm going to add in the other 2 pieces. So 3 times 3 is 9, and that represents all of the parts in the whole number. And then I'm adding in the other 2 pieces, and I get 11 thirds. Let's take one more look at that with another example. So if I have 2 and 2/5, 2 and 2/5. Again, I know that in order to make a whole, I have to have 5 pieces in it, because I'm working with fifths. So one of these holes has 5 pieces. The other hole has 5 fifths. So that's 10 fifths plus 2 more fifths would equal 12 fifths. Again, 5 times 2 plus the other 2 pieces. And if we look at that as a model, okay, there's 1 hole, there's 2 holes, and there's 2 fifths. Or 2 wholes with 5 pieces each, that's 10, plus 2 more pieces equals 12 fifths.